what we will do is we will now go to the lecture and then take this. Hello and welcome. In this lecture we are going to look at how different objects, variables and functions are named in a C++ program, and we are also going to learn about type declarations. So here is a quick recap of some topics relevant to what we are going to study in this lecture. We have seen in an earlier lecture the structure of a simple C++ program, where we saw a main function, and within the main function we saw different variables and their declarations. We are going to look at variables, declarations and some related topics in this lecture, building upon what we have studied earlier. So this is the overview of this lecture. We are going to look at how names are given to different objects in C++. We are going to have a very high level overview of type declarations and how these are indicated in a C++ program, and we will illustrate these through names and declarations of variables and functions in a C++ program. So in C++, there are different kinds of computational objects, and names must be used to represent these objects. Each object typically can have a value of a certain type, and so we must also associate a type with every named object in a C++ program. Now the value associated with a named object can change as the program executes. However, the type associated with the object stays the same. Even constant values used in a program can be thought of as objects of a certain type whose values do not change as the program executes. So what we are going to see in this lecture is how to assign names to different objects and how to declare their types in a C++ program. A name in a C++ program is any sequence of characters where the characters could include any character from uppercase A to uppercase Z, lowercase a to lowercase z, the number 0 to the number 9, and you can also use the underscore character. However, when you are forming the sequence of characters, you have to remember a few do's and don'ts. For example, you cannot start a name with a digit like 0 to 9. For example, 1 myvar is not okay because it starts with the number 1. Similarly, a name cannot be a C++ keyword. We have already seen certain keywords like namespace, int, return and so on. So you cannot use any of these keywords. Also, although they are a sequence of characters from these allowable characters, but because they are reserved keywords, they cannot be used for names. A name can start with underscore, or it can start with any letter from uppercase a to uppercase z or lowercase a to lowercase z. For example, you can have a variable named like this, underscore myvar1. A name can usually be of any length. However, some compilers may limit the length to some large number, but in reality this is not really a practical concern. Now it is very important to assign meaningful names to whatever objects you are using in a program, and the importance of this is very high if you want your program to be readable. For example, in a big, let us say 1000-line program, if I have a variable named average marks, just the name of the variable tells me what this variable is going to be used for. It is going to be used to store the average of some marks. Whereas if instead of using this variable name, if I had said variable xyz, then it becomes very difficult to understand its purpose, and one has to look at the various places where this variable is used in order to figure out what this variable is being used for in the program. So by assigning meaningful names to variables in programs, you can indeed make your program much more readable. Now, as I said, every object must be associated with a type, and C++ allows different types of values. For example, I have indicated in red here different types that are allowed in C++, and this is certainly not a comprehensive list of types. C++ allows much more types, and we will see more of these as we proceed in the course. So here I have indicated some types: char for character, int for integer, float for floating point values. We will see what these are later on. Similarly, double is for double precision values. Once again, we will see what these are. You could also have the type void, which means that a variable or an object of this type does not have a specific value associated with it. Similarly, you could have the type bool for a boolean. Now, the type of an object must always be declared before its use. You cannot use an object until you have declared its type already. The way you define the type of an object is by saying type name space object name. For example, I could have integer midsem marks or character yes no response. Clearly, I have used variable names here which indicate what their purpose is, and this is telling what kind of value can be stored in this variable. Now, why are type declarations important? Because the compiler is going to use these declarations to allocate an appropriate amount of memory space based on the type to store the values that are going to be stored with this variable. So, for example, if midsem marks is of type integer, the compiler is going to allocate 4 bytes to store the value of that integer, whereas if yes no response is of type character, the compiler is going to allocate 1 byte to store the value associated with this variable. So, as you can see, these type declarations serve a purpose much more than readability of the program. They are actually used by the compiler to do memory space allocation for different variables. Now, you can also use certain qualifiers to types. For example, I could say short int, which basically says I am going to store an integer, but I am going to just need 2 bytes to store the value of this integer. An unsigned int, which is basically saying an integer, but I want to treat it as an unsigned number. I do not want to have a sign bit for this integer. A long int, typically an integer is 4 bytes, but this could be used to say that I am going to store a very large integer value. Please allocate 8 bytes. Some compilers will, however, use 4 bytes itself for long int. Or I could have unsigned char, which means that use 1 byte as in a character, but I am going to use it for storing unsigned integers. So, the compiler uses the qualifiers that you can give to types. For example, int is the type and short is the qualifier, char is the type and unsigned is the qualifier. The compiler uses this qualifier information to decide how much space to allocate for a variable and how to interpret the stored values. Now, types are important, and similarly names are important not only for variables, but they are also important for functions in a program. Now, what is a function? We have already discussed about this very briefly when we were talking about the basic structure of a C++ program, but here is a quick look at it again. A C++ function is basically a computational subtask which you encapsulate within braces and then you give it a name. So, once again you see here a name is needed to identify a C++ function which will do a computational task or subtask. And the names to be used for functions must follow the same rules as for variables and other objects that we have just seen. Now, a function can also accept optional input parameters and it can return values, but these input parameters must again have names and they must have types, and similarly the return value must have type. And of course, when a function has parameters, what it represents is a parameterized computation. We will quickly see an example of this. This was a friendly summing program that we had seen in an earlier lecture. It reads in 2 numbers and it outputs their sum. Now, I could also write a function to add integers which takes 2 parameters called a and b, computes their sum and returns that value. So, for example, here a and b are input parameters, and note that they also have names and they have types. The function itself returns a value of a certain type. So, the function itself is associated with a return type, here an integer, and the function also has a name, just like a variable has a name. So, here the name of the function is add 2 ints, and the same naming rules apply for naming functions as for variables. Just like variables, the name and type of a function must also be declared before its use. For example, in the yellow box here, I have separated it into 2 panes just so that the entire program fits into this slide, but you can read this program as starting here in the left pane and after that going into the right pane. So, here the part highlighted in red is a declaration for a function. It says this is the name of the function, these are the input parameters of the function, these are the types of the input parameters, these are some names of the input parameters, and this is the type of the return value of this function. So this is a declaration for the function, just like we have a declaration for variable. We must declare a function before we use it. So this is the declaration of the function. The main function here reads two numbers a and b, and then it invokes this function add two ints, passing a and b as parameters to this function. We will look much more about how to invoke functions and how to invoke functions in more complicated ways later during the course, but I am just trying to illustrate here that in a program, if you want to use a function, then that function must be declared earlier, and the declaration must contain the names and types of the input parameters and the type of the return value, and of course this is the body of the function definition which tells you what the function does. So in summary, what we have seen in this lecture is that there are certain rules for assigning names in C++. Names need to be associated with variables, functions, and in general to any computational object that you have in your program. Type declarations are absolutely essential for any named entity in your program. Variables must have type declarations, functions must have type declarations, function parameters must have type declarations, function return values must have type declarations, and we have looked at some commonly used types just to illustrate how to write a program with named variables, functions, and how to declare the types of these variables and functions. Thank you. Okay, so are there any doubts? Yes. What is the use of int main and return 0? So it's just like, so main is just like any other function, and we said that every function must have a name and a return type. So int is the return type of main, and so as we said that just like for variables, so in general a function accepts some input parameters and returns a value. In general, that's the general template for a function. We will look at functions in much more detail in a subsequent lecture, but at this point you can think of every function must have 0 or more input parameters and it must have a return value. Every value must have a type. So the function must have a return type, the input parameters must have types, right? Because the compiler needs it to figure out how much space to allocate. When a function returns, how many bytes should it return that value in? When it's accepting inputs, how many bytes is it accepting the inputs in? Right. So main is just like any other function. Its name is main, that's kind of like a reserved name, and its return type is int. And so when we say return 0, we are basically saying return the value 0. 0 is an integer. So that's all that's there in main. I mean, we'll see that we can also return other integers. We can say return 25. That is also fine. So when the function returns, it will return the value 25 to whoever called it. Yeah? Oh, what was the use of the function on this side? So suppose I did not have this and I just told int main, and at this point I said add two ints. How will the compiler know what should add two ints do? The compiler doesn't understand English language. Huh? Oh, I could have written a plus b. I could have written c is assigned a plus b. That is what I did here. Right? So this is a program which doesn't invoke any function. I mean, it invokes only the main function, but the main function doesn't invoke anything. It just adds two numbers a and b. What I'm saying is the same summing functionality, the same summing purpose can also be done by this program, where the main function is not adding a and b directly. It is calling another function which is doing the job. For example, instead of add two ints, I could write another function here, raise a to b. And that function would just, just like here, this is a function. So as I said, a function is just a computational subtask. I have given it a name. So here the computational subtask is to add two numbers. I have given it the name add two ints. You might give it the name, add the number 2 and then integers, whatever name you want to give. So over here, instead of directly adding a plus b, I am saying pass these two parameters to this computational subtask. But then I have to specify what this computational subtask must do, and that is what is specified. So when I say C is assigned add two ints AB, it's like an assignment statement. So I must get a value from the right hand side and store it in the left hand side. So if the right hand side has to give me a value, it's just a computational subtask. So it has to return me a value. No, so this is the namespace of this function. Oh, so you're saying that I have put C here and I have put C here and that's confusing.
There should not be a need to declare int again C.
Okay, so suppose I had int ABD and I wrote D over here and I said sum is D. This would also work. In fact, it would give you exactly the same output. The variables here are for this function to use. The variables here are for this function to use, right? So here I am saying you use this variable, it's like a drawer, do some computation, put something in the drawer and then return C. Open the drawer, look at its value and give this value back to whoever called me. Now when that guy gets that value, it doesn't know which drawer it came from, it just gets that value. So this is the name of the drawer in this computational subtask. When I say return C, it opens the drawer C for itself, picks up that value and says here is what you wanted. The guy who is getting it has no idea from which drawer it came within this function add to int. So it just gets a value back here and it says whatever value you gave me, I will now put in my drawer named D. Even if I put a C here, that would mean C for the function main, it's main's drawers, and this would mean C for the function add to ints, which is, so in any case we are going to look at functions in much more detail in a subsequent lecture. There will be one entire week of functions. But you know, in this lecture the whole idea was to say that functions must also have names, they must also have types, and the rules are the same as for variables and right. Okay, so now let's quickly do a quiz problem before we disperse. And here is a program and we are asking how many problems can you identify in this program. So basically, you know, if I give this program to a compiler, it will be very unhappy and it will say, you know, lots of problems are there with this program. So we are just trying to ask you that given that whatever you have studied, whatever you have seen in these lectures, how many problems can you identify in this program? Okay, so please write down in your notebooks. I mean, this is only the kinds of statements that we have used, right? There is no function call other than main over here. Uses some declarations, some input-output statements, some assignment statement with addition and all of that, return statement. So this is all the features that you've already seen. The question is that a C++ compiler would not consider this as a legitimate C++ program, and from what you have studied in the lectures, you should be able to figure out lots of problems. So there are more than one problems in this program. So we want you to figure out what they are. Okay. Please swap your copies. How many of you think there are just two problems? Okay. And your neighbor doesn't agree?
He didn't understand our problem.
So what is it that you didn't understand, Emma?
For example, we write C in and after that we give two arrows and then we wrote B. And then why didn't we write once again two arrows?
Like, no, so that has got nothing to do with namespace. Namespace is saying that when I am talking about B over here, it is B from the namespace std. It's like saying when I am calling Rishabh, I am calling Rishabh from section D1 or whatever. So that has got nothing to do with namespace. Namespace is just saying when I indicate a variable, I am telling it it's variable from where. So let us see how many people said that there are two problems. Okay, so let's hear what those two problems are. Good. So first, a variable name cannot start with a number.
From a number.
Okay.
And secondly, the variable second a was used before its declaration.
So the variable second a was declared here and it was used before it.
Yes.
So all declarations must appear before their usage. Okay. That's it. Those are the two things. Okay. Now, how many of you had 3? Okay. So let's ask yes from the. Okay. So you're adding a float and an int and you're storing it in an int. Okay. So that you think is a problem. Anybody else with additional problems? Yes. Oh, so you mean after this comma there is a space, that's a problem. Okay. Any more? Yes?
P out first a plus second a minus b should be enclosed in double quotes because it's a string.
No, but this is not a string. So these are all numbers, right?
But then we don't have a variable in which we have stored this string. So we means to output.
But there is a value associated with this, right? If first A has a value, second A has a value and B has a value, there is a value associated with first A plus second A minus B, and we are saying output that value. So I guess what you are saying is we are using something which is not just a variable in cout,
yes.
okay? Yeah.
So if we had double quotes,
then it will become a string.
Okay.
Then it will just print 1sta space plus, right? I won't get the value. If you put double quotes, it will become a string.
Okay.
Yeah.
Since the function is not in integers, I think we should write float before.
No, the function is returning a value, right? It's returning 0. That is an integer. Any more? Yes.
Since second A is written before float second A, no?
So that is the
first we have to create.
Yeah, so that somebody else also pointed out that this variable is used before it is declared. It's the same thing. Yes, over there.
Sir, there is no string for user to give input.
There is no string for user to give in. Okay.
And
so,
sir, there is also another problem. There is no type defined for B.
so B has the type int.
Sir, int is before first A. So that is for
so-
both of you.
So yes, it's just like Dumbos to Dumbo we are saying use locations A, B, C. So it's int A, B, C.
Okay.
Okay.
Sir, there should be no semicolon after return 0.
There should be no semicolon after return 0. Okay.
And sir, one more thing, there should be a semicolon after that IO stream.
There should be a semicolon after IO stream. Okay. So we've heard lots of things. Let me try to sort of quickly answer the different things. So indeed, this is a problem. 1sta is a problem because the name can't start with the number 1. This is indeed a problem. You can't use a variable before declaring it. Okay. Can we add a floating point number to an integer number and can we assign that to another integer or floating point or whatever it is? So it turns out that this can be done and we'll actually look at it in the next lecture. But it was good that you pointed this out because now that you've pointed it out, I hope you'll be more careful when we're actually discussing this. So we'll see that this can be done. And in fact, when we do such things, the type of the value that is computed here is sort of the most expressive one. So it will become float. If you add a float and an int, it will become float. And when you try to assign it back to an int, again it will get truncated and it will get assigned to an int. So we'll see that. There is no semicolon after return. Every statement is followed by a semicolon, right? So a semicolon basically denotes the end of that statement. So we'll actually see the use of this statement, use of semicolon to denote end of statements also in one of the lectures next week. So hopefully you'll pay attention to that. Hash include IO stream semicolon. Why do we not use semicolon over there? So this is a good question and the simple answer to that is, this is a compiler directive. This is not an instruction that is executed by the program. However, this is also another compiler directive. It's just that the syntax says that we don't need a semicolon here, we just specify. But now that you mentioned it, I hope all of you will remember not to put a semicolon. Somebody said iostream.h. So, by default, the compiler, you can put iostream.h, but by default it will put that extension because all the header files are supposed to start with .h. Okay, then there was some other thing about space B. So all these spaces are completely ignored by the compiler, right? So unless it comes within a string or unless you use the character space. So spaces are completely ignored. This, as I said, this is not a variable but a kind of arithmetic expression. So as far as cout is concerned, it is saying we are asking it to output a value. What is the value? It could be the value in a variable. It could be the value obtained by computing something. So these are called expressions, which we will again see in the next week's lecture. So really there are two errors in this, okay. And I'm glad that several of you got it, but it's also important that several of you pointed out other things. And now in next week's lecture, if you're attentive, you will see that we will actually address each one of those. That why is the semicolon used, why are expressions important, and all of that, okay.